All right, guys, we're about to do our last lesson before the next test. So this will be the last new lesson. Then on the next day, we'll do a review, and then we'll be ready for the test. So we're going to look at lesson 5, states of matter. I will have the actual questions posted here, and I will have the PowerPoint slide posted right here. So notice how that's going to work. In support materials will be the PowerPoint slide, and then in this thing for the week is where you actually see the lesson. All right, so we're going to look at the states of matter, how things change. And it goes back to the kinetic molecular theory, which is simply that matter is made up of tiny particles called atoms, and all the atoms are in constant random motion. So that means everything is in constant motion at the small molecular level. Remember, we discussed a week or so ago that if the particles in matter were to absolutely stop, we call that absolute zero, and that's impossible. As you add energy to a particle, the motion increases, and as you take away energy, the motion decreases. And what will hold matter together is the attractive forces between those particles. So I want you to imagine like holding on to two people. If they're standing still, it's easier to hold on to somebody. But if those people you're holding on to start trying to run as fast as they can and going all over the place, it's harder to hold on to them. And so it's the same way with matter. There's an attractive force that holds the particles together. But if you add enough energy, then what will happen is the motion of the particles, the energy that's providing the motion, is going to overcome the attractive forces. And what that will do is it'll push them at a distance between each other. So let's take a solid. Think about what's happening in a solid. It's just sitting there. All the particles are staying in the same shape, in the same formation. So what's happening is the attractive forces are basically overpowering whatever energy is trying to create motion. Okay, so look at whatever solid is around you. Like right now I'm looking at my desk. And all these particles, they must have motion because everything has some motion, but these little particles make up my desk. The attractive forces is holding them together so tightly I can't see any movement within those things. So what happens in a solid, the volume is going to always be the same. So my desk always takes up the same amount of space, and the shape will always stay the same. So a solid, the attractive forces are so overpowering, it takes up the same amount of space and it stays the same shape. Now let's think about a liquid. Now in a liquid, so like I have a cup of water here, and there's not particles of that liquid flying all over the room. If it was, everything would get wet. They're staying inside the cup, but as I move the cup, they move with it. So if you take, like right now, the liquid is in the shape of my cup. If I pour it into a bottle, it takes the shape of the bottle. Now, if it's 1 liter of water, no matter what I pour it into, it will always be 1 liter of water. So in a liquid, you always have the same amount of volume, but it does not have a fixed shape. Liquids will take on the shape of whatever they're in, so that you have the same amount all the time. That's what volume is, but your shape can change. And then lastly, gas. If something causes a bad smell on one side of the room, eventually you'll smell it on the other side of the room, which tells you that gases won't stay in the shape. So like if you have some type of horrible smelling gas inside of a bottle, and then you open the bottle, well, that gas is not going to float through the room in the shape of a bottle. That gas is going to disperse and fill up the entire room. So what gases do, they don't have the same volume. They take up whatever amount of space they're in, and they don't have a fixed shape. So they have neither fixed volume or shape. Neither one of those stay the same. They take on whatever shape, whatever size of the object that they are in. So that's how gases work. So then what will happen, we have 6 phase changes to look at. So what happens, you add thermal energy, and it heats up the object, and it makes it go from a solid to a liquid to a gas. Or the opposite, if you remove thermal energy, it'll go from a gas to a liquid to a solid. All right, so solid is low amount of energy. Add some more energy, the particles move faster, they become a liquid. Add more energy, they move faster, and they completely break through the attractive forces, and they become a gas. So let's look at this. Condensation. So condensation is when you go from a gas to a liquid. All right, so you might want to write this down as we go through it. It'll help when you do the questions. Condensation goes from gas to liquid. So what happens is as you lose energy, then the particles slow down, and you can almost imagine that they can stick. Once they slow down, they stick to each other, become a liquid. And then vaporization is liquid to a gas. And so you have a liquid, you add energy, particles move faster, and they break the attractive forces. Freezing is liquid to a solid. So this takes place. What happens here is the kinetic energy decreases and the attractive forces completely dominate the movement. And instead of moving freely in the form of liquid, they get stuck into a solid. And then melting is the opposite. Imagine your ice cube, you add some heat, the little particles move faster, and they go from a solid to a liquid. Okay, and then our last two, sublimation, deposition. Sublimation is when it goes from a solid directly to a gas. And so what happens is you have a solid, and the force of motion overpowers the attractive forces that are keeping it together. And then deposition, you go from a gas and you turn it straight to a solid. So the attractive forces overpower the motion, they stop it from moving, and it becomes a solid. So those are your phase changes. And then what I want you to do is from here, if you look at, we have the lesson on the states of matter. So what I want you to do, you can open up this PowerPoint, keep looking back. I want you to try to do this. So pause this video, go through it as far as you can, do the best you can, and then I'll go over it. So pause and then press play once you've tried it. Okay, so let's go over it, make sure you did it right. Losing energy, what's that going to do? Will losing energy cause the motion to increase or decrease? Losing energy will make it decrease. Solid particles have predictable and fixed. That'll be both volume and shape. Think about the desk. It takes up the same amount of space and it has the same shape all the time. What about liquids? So what's predictable on a liquid? Do liquids always stay in the same shape? No, they take whatever shape of the object they're in. So the volume is the thing that is predictable and fixed. And then in gas, do gases take up the same volume or shape? No, nothing's predictable and fixed. Okay, what was condensation? So remember, if you look back at the slides, condensation is going from a gas to a liquid. So condensation, a gas converts to a liquid, and if you go from gas to a liquid, you're losing thermal energy. Gas is the highest, solid is the lowest. So going from gas down to liquid, you're lowering your thermal energy. In sublimation, so let's look here. Sublimation, solid goes straight to a gas. So in sublimation, a solid turns to a gas, and gas is the highest thermal energy, so it gains thermal energy. Melting. I don't even think we have to look at the slide. What happens when your ice melts? It starts as a solid and it becomes a what? A liquid. And because solid is the lowest amount of thermal energy, it must be gaining thermal energy to become a liquid. And then lastly is deposition, not as familiar, gas straight to a solid. So deposition goes from gas straight to a solid, and since gas is the highest, solid is the lowest, you must be losing thermal energy. All right, so there's our questions for today. Make sure to go over this, make sure to understand it, and then tomorrow we'll have a review lesson, and then the next day we will be taking the test. So make sure that you're reviewing, make sure you understand this stuff. As usual, I'll have tutoring from 2 to 3 if you need any help. All right, you guys have a good day, and I'll talk to you soon.